Hello everyone. So today the question that we're looking at is question number 4 of summer 2009 9702. The question says a vertical peg is attached to the edge of a horizontal disc of radius r as shown in figure 4.1. They have shown us a peg with radius r. The disc rotates at a constant angular speed omega. A horizontal beam of parallel light produces a shadow of the peg on screen. Okay. At time 0, the peg is at P, producing a shadow on the screen at S. So this is the shadow right here. At time t, the disc has rotated through an angle theta. The peg is now at R, producing a shadow at Q. So this is essentially its initial position, final position, initial shadow, final shadow. A part says determine in terms of omega t and the angle theta. So we have to find the angle theta in terms of omega and t. So one thing that we need to understand is this theta here is the distance traveled. So when we want to find distance, we know that distance is equals to speed into time. So theta in this case is equals to speed, which is omega, into time, which is t. Simple, that is it. For the second part, it says in terms of omega t and r, the distance sq. Now the distance sq is this straight line like this. So we have to find this distance. Now we know that this distance is r as well. This distance we do not know and we should not be concerned with it. Well, so when we need to find out this distance sq, we can see that we can use sine theta, because sine is equals to opposite, which is this distance sq, and hypotenuse, which is this r, because this is 90 degrees. Having said that, if you write sq is equals to sine of theta is equals to opposite, which is sq, divided by, let me write this in caps lock, divided by opposite over hypotenuse, which is r. Now if I were to write this in even in simpler terms to make sq the subject, that would have been r sine theta is equals to sq. Now this doesn't end here, because they have told us that we have to write it in terms of omega t and r. We have theta here, which we need to remove. So the simple way to do is, in a part we found what angle theta is. Theta is omega t. So all you need to do is you just need to replace r sine theta with omega t is equals to sq, and that is it for the second part as well. Now moving on towards the B part, use your answer to A2 to show that the shadow on the screen performs simple harmonic motion. Every time simple harmonic motion comes up, there is this one equation that we need to keep in our mind. That is, A is equals to minus omega square into r. Why? Because simple harmonic motion can be defined as the displacement from a fixed point is directly proportional. Let me write this down, because only then you will be able to understand this equation as well. The displacement from a fixed point is directly proportional to acceleration but in opposite direction. The reason why I have written this in caps lock, this opposite direction means this negative sign. The displacement from a fixed point is directly proportional to acceleration but in opposite direction. Now, how does this equation right here, relates to this equation? Now, there are three main equations for simple harmonic motion which will help you understand this question as well, which is x is equals to x naught sine omega t, v is equals to omega square x naught sine omega t, and we have, this is omega x naught sine omega t, and we have a is equals to minus omega square x naught sine omega t. Now, how did this equation turn into this and then into this? This is by differentiation by t. This was differentiated by t to form this, and then this was differentiated to form this. Now we can see that this equation, let me just change the color for better understanding. This equation right here is the same as this equation right here. We have sine omega t, we have x naught, which is odd here, sq is equals to x. So we can say that this equation, the equation in A2, is the solution to the equation of simple harmonic motion, which is A is equals to minus omega square x. So we will write the equation in A2 is the solution of the equation of simple harmonic motion, which is A is equals to minus omega square x naught, and that is it. Done for the B part. Now we have the C part that says the disk has radius r of 12 cm and is rotating with angular speed omega of 4.7 rad per second. Determine for the shadow the frequency. You need to know the formula for this. We know omega is equals to 2 pi into f. The reason why we're using these is because we know that it's simple harmonic motion, and we know that it's performing a circular motion, so we can apply this, and then you need to just plug in the values. Omega has been given to us as 4.7. And then you just need to write 2 pi, the value of 2 pi into frequency, which we have to find. When you plug in this value in calculator, you get 0.75 as your answer, which is our final value. And then you have its maximum speed. Now, for the maximum speed, we will be using v is equals to r omega, which is one of the formula for the circular motion. V is equals to r omega. Now some may argue that why can't we use v is equals to omega x naught. That is because omega x naught cos omega t hasn't been given to us, so we have to use this because it's a performing circular motion, so we need to use v is equals to r omega. And simply when you plug in the values, you have the radius as 12. I'm not converting it into meters because the formula is the units, my bad, is centimeters per second. So 12 into omega is 4.7, and the answer you get is 56.4. And this is it for the second part as well, and that is for question number